Hi, 7th grade. Welcome to lesson 2-6, Apply Proportional Reasoning to Solve Problems. This is also the last lesson of the topic. By the end of the lesson, I want you to be able to say, I can determine whether a relationship is proportional and use representations to solve problems. Let's solve and discuss it. Xander and Pedro are at an ice cream social. For every scoop of ice cream, Xander uses 1 cup of fruit topping. Pedro uses 1 more tablespoon of fruit topping than the number of scoops. If Xander and Pedro each use the same amount of fruit topping, how many scoops of ice cream does each use? Well, first thing, I noticed that Xander uses cups of fruit topping and Pedro uses tablespoons. So, if we look here, it tells us there are 2 tablespoons and 1/8 of a cup. So if we want, we can just do scoops and tablespoons. So we can make a table for Xander. And we can also make a table for Pedro. I'm going to do S and T, scoops and tablespoons. So first, Xander uses 1/8 cup of fruit topping, which is 2 tablespoons of fruit topping. And that's with 1 scoop of ice cream. If Pedro does 1 scoop of ice cream, he'll use 2 tablespoons of ice cream, 2 tablespoons of fruit. So then Xander will use 2 scoops, will be 4. Pedro's 2 scoops will be 3. Xander's 3 scoops will be 6. Pedro's will be 3 and 4. And it will go on forever and ever. The only time they'll use the same amount of fruit topping is at 1 scoop. They'll choose 2 tablespoons of fruit topping with 1 scoop of ice cream. For which person, Xander or Pedro, is the relationship between the quantities of ice cream and fruit topping proportional? Explain. Xander, because there is a constant rate of 2. Example number 1. The ratio of collectible cards Deshawn owns to that of Stephanie owns is 5-2. Stephanie has 36 cards. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards? Explain. So, if Deshawn has 5 cards, Stephanie has 2 cards. If Deshawn has 10 cards, Stephanie has 4 cards. And it goes on and on like that. So, my favorite representation here is the table. It shows me Deshawn's 5 to Stephanie's 2. We know Stephanie has 36. So to go from 2 to 36, we multiply by 18. So whatever you do to the bottom, you do to the top. But then we want to know what's going to happen if they sell half their cards. So that means we got to divide it by 2 or multiply by 1/2. Whatever you do to one side, you do to the other. So Deshawn will have 45 over 18, but 45 over 18 can both be reduced by 9. So if we divide by 9, you get 5 over 2, which is the same ratio we had from the beginning. So if the number of cards change by the same multiple, the ratio that relates them is equivalent. It does not change. Let's try it. After selling half their card collections, Deshawn and Stephanie each buy 9 new cards. What is the ratio of the number of cards Deshawn has to the number of cards Stephanie has? So Deshawn has 45, and then he buys 9 new ones. So 45 plus 9 gives me 54. Stephanie has 18, and she buys 9 cards. Well, 18 plus 9 is 27. So now the ratio is 54 to 27. Why did the ratio stay the same in the example but change in the try it? Well, we need to prove that it changed in the try it. 54 over 27. They're both divisible by 9. 54 divided by 9 gives me 6. 27 divided by 9 gives me 3. Oh, I can reduce again by 3. So that is 2. That is not the same ratio we had before. So the ratio stayed the same in the example because we were multiplying and dividing. It changed in the try it because we added. It would also change if we were to subtract. So always multiplying and dividing keeps the same ratio. Example 2. Recognize when to use proportional reasoning. Martin is 6 years old when his sister Cassandra is 3 years old. How old will Martin be when Cassandra is 6 years old? Make a table to find Martin's age. Well, every year you get a year older. So if Martin starts at 6, the next year it'll be 7, 8, 9. If Cassandra starts at 3, when Martin is 7, she'll be 4. When Martin is 8, she'll be 5. When Martin is 9, Cassandra will be 6. So to go from 3 to 6, you multiply by 2. But 6 times 2 is not 9. So this is not a proportional relationship. There's no constant multiple. So you can't use proportional reasoning. Example 3. Apply proportional reasoning. A video streaming service charged Brian $143.84 for a full year of access. Brian thinks he was not charged the correct amount. What should Brian say when he calls customer service? Well, it says video streaming is $8.99 a month, and there are 12 months in a year. Well, $8.99, that's our constant of proportionality. That's our k value. So that's how they made this equation. Remember, y equals kx. And x stands for the number of months, so they put 12 in. Did $8.99 times 12. So Brian should have been charged $107.88. He should ask customer service for a credit, meaning they need to give him back money because he overpaid. That's $35.96. We find that by subtracting. Another way to do it is to put in the amount he was charged for y and solve for x. The $8.99 is bothering the x, and it's attached by multiplication, so we can cancel it out by division. So Brian was charged for 16 months, actually. So we should ask customer service to give him 4 months of free online service. Let's try it. A florist makes bouquets that include 50 white flowers and 70 red flowers. So we start 50 white, 7 red. If the florist orders 1,050 white flowers and 140 red flowers, there will be leftover flowers. White, can the florist adjust the order so there are no leftover flowers? Let's make a table. White, red. If we have 50 white flowers and 7 red flowers, and then we have 1,050 white flowers and 140 red flowers. Well, I can see a relationship between 7 and 140. 7 times 20 will give us 140. Let's see. 50 times 20 is equal to only 100. Oh, I'm sorry. 100, right? Yes. 100. Oops, I want to erase that. 50 times 20 is 100. So there are going to be leftover white flowers. If we do 1,050 minus 100, that will give us 950. So the florist can order only 100 flowers, 100 white flowers. Key concept: think about how two quantities are related before you decide to use proportional reasoning to solve a problem. So basically you got to check to make sure it is proportional so that you can use proportional reasoning. You cannot use proportional reasoning to solve this problem because Josh's age is not a constant multiple of Evie's age. All right, 8th grade or 7th grade, let's say it. I can determine whether a relationship is proportional and use representations to solve problems. Have a great day.